to back. It's every 50 minutes, so let's turn this around. Our next topic, orchestrating agentic workflows with governance and trust. We have our senior solutions architect from SaaS. Ladies and gentlemen, please welcome onto the stage, Sin Ruli.
So, hi everyone, thank you for attending my session today. I'm Sin Ru and I'm from the Global Technology Practice team at SaaS. So today I'll be talking about how we can orchestrate agentic workflows with governance and trust. So in other words, what do we need when it comes to building future-ready AI agents for enterprises? So we have progressed from large language models to AI agents, where AI agents can now autonomously take actions on behalf of humans. They can also adapt to changing environments, and they can enhance the productivity of humans by executing complex tasks. However, there are challenges that undermine the effectiveness of AI agents in the enterprise world. So we need accuracy, consistency, and the transparency of how the agent came to that decision. So in order for customers to feel comfortable or confident when they're using AI agents. In fact, in highly regulated industries, they are not allowed to use AI agents if they cannot achieve these criteria. So what if the AI agent is wrong, right? When do we need to escalate it to a human for review? So in some cases, we want the AI agent to do the heavy lifting, but we still want humans to come in where it is crucial, where the risk level is high, and where the impact of making the wrong decision is larger. So sometimes we need to bring in subject matter expertise that cannot be automated. So this is where we want human in the loop. Then we also need to consider the ethical and regulatory aspect of things. So is the agent ethical, and does it comply with regulatory and organizational standards? So this is where we think that the future of enterprise AI agents is hybrid, right? Fully autonomous agent, which is how the industry defines AI agents today, they have some limitations. They struggle in the enterprise environment. And why is that so? This is because LLMs are probabilistic in nature. So when you ask the same question twice, you might not even get the same answer. So even if you write a super good prompt, right? So there needs to be some sort of accountability in the system to figure out and figure out where you want human in the loop. Where are you fine with handing over the degree of autonomy to the LLM? For example, in a loan application scenario, you might not want to use an LLM to make the decision for you in terms of who is getting their loan approved or not. So this is where you might want to bring in some sort of deterministic components, say a scorecard model or a logistic regression model to determine who is getting the loan approved and some sort of business rules behind that. So this is why the future of enterprise AI agents is hybrid. So these are some of the main use cases that we hear from our customers, and these are all not new use cases, right? Where do we see the value of large language models in these industries? For example, in a call center transformation scenario, this is where personalization is key. So large language model can bring a huge value in this case. Whereas in terms of processing insurance claims, right, it's a long, tedious process. It takes some time. You have to wait weeks in order for your claims to know the status of your claims, whether they are approved or rejected. So this is where large language model can help speed up the time to make that decision. And then in a production optimization scenario, So these are things that have to be done regularly. These are complex scenarios that have to be done again and again. So this is where large language models can also be used to help the humans do better. So what do we think, what is required for us to build and design an AI agent? Firstly, it needs to be on top of some sort of decisioning platform where you can bring in business logic. So it needs to follow some sort of business logic. You must have the ability to access data, whether it's internal data or an external call to, let's say, a credit bureau. You must have the ability to bring in deterministic components like AI models, so not just large language models which are probabilistic in nature. Then it is about balancing human in the loop and out of the loop. So it really depends on your use case, the risk appetite that you have for your use case, how much control you want over here. And then lastly, we talk about governance. So the way you come up with that decision, it has to be tracked, right? You need to understand the lineage of how the decision reached that, how we reached that decision. So these are the various components that make up what's necessary in an agentic AI workflow. So starting with the left-hand side, we have the building blocks. So this is where you can bring in data. So whether it's like a RAG vector store, or whether you're trying to access your enterprise data, access third-party applications. You must also think about the tools that we want to incorporate into the large language model. It could be simple business rules, it could be AI and machine learning models. And then the last piece is the large language model. So you have a repository of prompts that are the best practices that your organizations have created. Or it could be a repository of large language models, really you're agnostic. You can choose different ones depending on what suits you best. Then in the middle, it's about balancing human in the loop and human out of the loop, right? Sometimes you can have AI agents itself is really specialized, so they are very good at executing a single task. But in a normal business scenario, it's more complex than that, right? You sometimes need multiple AI agents that are orchestrated within the same workflow. Lastly, deployment. You can deploy it in real time or in batch or streaming, and deploy it into the interface that you want. So whether it's a chatbot or web application, it's up to you. So let's dive deeper. Let's look at this example. It's a complaints agent, right? Where we're trying to manage and summarize previous customer complaints to understand further. In the first part, we are trying to augment the enterprise agentic workflow with data. So it could be a query to an internal database, it could be a call to an external service. And then we bring in large language models wherever we need, wherever we find the greatest value. And sometimes, not just large language model, you want to bring in analytical models. And how do we combine those with business rules? Next is to implement guardrails, right? Large language model, you cannot really predict what kind of answer it's going to come up with. How do you implement guardrails to check that the responses are accurate, or how can you check whether they contain any sensitive or private or confidential information you want to block them out? And how do we bring in human in the loop? So this is where, in some cases, you might want to escalate it to a human for review. Lastly, it's about the ability to store the memory. So this could be a session memory, so that when you're conversing in a chatbot, you don't have to repeat yourself. It's able to understand the previous prompts that you have inserted into your chatbot before. Or sometimes you want to store the conversation history beyond the session, so that you can personalize your future interactions with the customer. So now, we've talked about building AI agents, but sometimes we need more than one AI agent, so how can we orchestrate a multi-agent system? So let's look at this example, which is a financial advisor agent that comprises of different tools. The first one was the complaints agent that we saw, and then we have the churn agent, as well as an email agent that we would like to use to maybe send a report at the end of it. So this is how it looks like. We have an orchestration, which is essentially the brains of the agentic workflow. It's trying to understand the customer's input and route it to the necessary agents, whether it's complaints, churn, or email. And it's able to understand that what are the information that we are missing out? Do I need to ask the customer for more information? Those are handled by the large language model. So let's dive deeper into the specialized AI agents. Each of them are focused on their own task. They cannot do another task well. So for example, the complaints agent is there to extract and summarize the customer complaints. The churn agent is there where you have like maybe a gradient boosting model to understand the probability of the customer churning, what's their risk level. And maybe you have another model that helps you to explain why the customer received this probability. Then we have an email agent that's able to generate a report and send to the respective stakeholders. Lastly, all of this is packaged into a single container and deployed as an endpoint. So whether it's a chatbot like you see here, or whether it's a web application, it's really up to you. And let's see how it looks like. So here we are saying, we're asking the chatbot, how likely is it that Mary will leave us as a customer? So it needs more details. It's asking for its full name and a customer ID in order to call the right agent. So now it's calling the churn agent behind the scenes, and this is the explanation. It's able to generate in real time the reasons why we think that Mary might churn. So another thing is that, okay, can you route this, whatever you send, whatever you reply to me, can you route all this information to this email address? Can you send a report to me? So it's going to do that, and this time, the same agentic workflow is able to understand the customer's intention and route to the email agent instead of the churn agent. And we'll see this report in just a bit. So the email is sent successfully. It called the churn agent, and here we have a churn report for Mary Smith. Lastly, to sum up, there has to be some sort of built-in governance, right? Not just the AI agent itself, where we want to see the lineage as to how the decision came about, but also an end-to-end governance, because there are data sets that you bring in, there are models that you train the data on, and this has to be governed. So you need to have end-to-end lineage in this case. So to sum up, what do we need in terms of building and deploying enterprise AI agents? You need to orchestrate, you need to have a good orchestration system that takes into account multiple AI agents. You need to have the ability to work with different large language models. So you must be agnostic so that you can bring in the large language model that is best suited for your needs. Then we talk about data protection, because you want to be able to access data, but at the same time control who has access to this data. And many other guardrails that we can see here. But to sum up and end off, before my time is up, you can reach out to me at a SaaS booth. I'm happy to hear more about your AI use cases, and we can dive further into the demo that you saw earlier. Thank you.